Hello everyone. So now let's look at practice assignment week 1, question number 1. So the question says match the system of linear equation in column A with their number of solutions in column B and their geometric representation in column C. So we have given three pair of equation in column A, three type of solution in column B and three type of geometric representation in column C. So let's look at each pair one by one. So first we have 3x plus 2y is equal to 7 and x plus 4y is equal to 12. So let's name them as equation 1 and equation 2. So if I multiply equation 2 by 3, then I will get 3x plus 12y is equal to 36. Let's name it as equation 3. Now let's subtract equation 1 from equation 3. So equation 3 is 3x plus 12y is equal to 36. Equation 1 is 3x plus 2y is equal to 7. So if we subtract these two equations, we will get 10y is equal to 29, y is equal to 29 by 10. So if we put this result in equation 2, that is from equation 2, the equation 2 is x plus 4y is equal to 12. So x plus 4y is equal to 12. X plus 4 into 29 by 10 is equal to 12. X is equal to 12 minus 116 by 10. So x is equal to 4 by 10. So we got only one point, that is the intersection of these two lines represented by these equations. So as we only got one unique point, so these system of linear equation will have unique solution. That is, the first will match with C, unique solution. And we know in the unique solutions, the line represented by the equation will intersect only one point, and that is given in option 2 or in the geometric representation column C. So 1 will match with C and 2. So that is in option 1. So that would be correct. While on option 2, it is given that 1 will match with A. So that will not be the case because it is in unique solution, not infinite solution. So it is wrong. So now let's look at second pair. So for second pair, we have 2x plus 3y equal to 5. 2x plus 3y is equal to 5. And we have 8x plus 12y is equal to 13. 8x plus 12y is equal to 13. Now again, name this as equation 4 and equation 5. So we're kind of figure out that the equation 5, this LHS side is 4 times the LHS side of equation 4. So that is, if we multiply equation 4 with 4, we will get 8x plus 12y is equal to 20. While equation 5 is 8x plus 12y is equal to 30. So let's name this equation as equation 6. Now, as we can see that the LHS side of these two equations, equation 5 and equation 6 is same, but their RHS side is different. So in that case, it will not have any solution. So no solution case. So the second pair will have no solution. So it will match with B. And in the case of no solution, the line represented by these equations will be parallel. So that is the first case. So that matches with the fifth option. Second will match with B and 1. While in the option 3, second will match with C that will not be the case as it is no solution. So this option is wrong. Now let's look at the last pair, that is third pair. X plus 2y is equal to 3. So third pair, x plus 2y is equal to 3, and we have 4x plus 8y equal to 12. 4x plus 8y is equal to 12. Now again, it is easier to find out that the second equation is 4 times the first equation. That is, if we consider this as equation 7 and equation 8, then equation 8 is same as 4 times equation 7. So they both are technically representing only one line. So in that case, infinitely many solution case will occur, as we have two variable but one equation, so infinitely many solution. So the third will match with A, infinite solution. And in the case of infinite solution, there will be only one line. So that is 3. Hence, in the option 4, that is saying that third will match with A, that is correct, but it will match with 2, that is incorrect, as 2 represents the case of unique solution. Hence, fourth option would be wrong. So now let's solve question number 2. So question 2 says choose the set of correct options. So we have to find out of these 4 options which of them are correct. And for checking their correctness, we have to use some properties of determinant or matrix multiplication. So I have written down some properties that we are going to use here, and how we are going to use them, we will see them by going through each option one by one. So let's look at first option. So option 1 says if both A and B are 2 cross 2 real matrices and determinant of AB is equal to 0, then determinant of A is equal to 0 or determinant of B is equal to 0. So we have given that determinant of AB is equal to 0. Then with this property, I can write it as determinant of A times determinant of B is equal to 0. Now, as these two will be some real number, so the product of two real number is given as 0, and this can only happen when either one of them is 0. So from here we can conclude that determinant of A would be equal to 0 or determinant of B should be equal to 0 for this case to be happen. So that's why option 1 is true. Now let's look at option 2. Option 2 says if A is a 3 cross 3 real matrix with non-zero determinant and K is some real number, then determinant of K times of A is equal to K cube times determinant of A. So option 2. So here we need some properties of determinant. So one of the properties of determinant says that if for a matrix A, if we are multiplying some row by some constant K, K can be any real number here, then let's say the new matrix is denoted by A tilde, then determinant of new matrix would be equal to K, that is the constant by which we are multiplying, times the determinant of original matrix. But notice here, we are multiplying only one row here. And as we are only multiplying one row, the K here is coming only once. But in the option, this K would get multiplied to each and every element of the matrix A. That is, determinant of Ka we have to find. On multiplying one row by once, we get K times determinant of A. Here, this A is of 3 cross 3 matrix. And here this K would go to multiply to each and every element of matrix A. That means each and every row of A. So this k will multiply to all the three rows, so it should come thrice. So it should be k into k into determinant of a, and that is same as k cube times determinant of a. Hence, option 2 is also correct. Now let's look at option 3. If A is equal to this matrix and A10 is equal to this matrix, where AN is the matrix multiplication A into A into A n times. So we have given this matrix A. Let's note down this matrix. Option 3, A is equal to 2, 0, 2. Okay, let's write it with black pen. 2, 2, 0, 2. Okay, so we have given this matrix. Then we have to check that whether if we are multiplying this matrix A by 10 times, that is A into A 10 times like this, then whether we are going to get this matrix or not. So let's try finding it out. So if we do the square of this matrix A square, before that we can also write this matrix A is 2 times 1, 1, 0, 1. I have taken 2 common from this matrix. So if we are going to find A square, this would be 2 times 1, 1, 0, 1 multiply 2 times 1, 1, 0, 1. So the scalar outside would get multiplied to each other. That would give us 2 square. And for multiplying this matrix, for the first row, first column entry, we will use this first row and multiply it with first column. That is 1 into 1 plus 1 into 0. So that would give us 1. And again 1 into 1 plus 1 into 1. So that would give us 2. Then next is 0 times 1 plus 1 times 0. So that would give us 0. Next is 0 times 1 plus 1 times 1. So that would give us 1. So this is our a square. Now if we try to find the a cube, then a cube I can write as a square times a. So we have already found a square, that is 2 square times 1, 2, 0, 1. And our a is 2 times 1, 1, 0, 1. So again, these scalars 2 square and 2 will get multiplied, will give us 2 cube in the matrix. So 1 into 1 plus 2 into 0. So that would give us 1. 1 into 1 plus 2 into 1. So that would give us 3. 0 into 1 plus 1 into 0. So that would give us 0. And 0 into 1 plus 1 into 1. So that would give us 1. So if we stop for a moment and try to analyze the pattern, we check that when A is power 1, then our matrix is in this form, that is 2 power 1 times 1, 1, 1 here, and while second of first column entry is 0. And when we do the square, this 2 will get to the power 2, and here these ones will remain same while this one will become 2. And on the cube, this 2 will go into the power 3, and this one still remains same, but this 2 now becomes 3. So we can kind of analyze one pattern that for this matrix A, if we do it for n times, then it should be like this: 2n times 1 n 0 1. And in the question we are asking to find a power 10, so that would be 2 power 10 times 1 10 0 1. So that matches with the option that is given here, that is 2 power 10, here 1 1, and here it is 10. So option 3 is also correct. So now let's look at option 4. So the option 4 says the number of scalar additions to be done to compute the matrix AB, where A is a 3 cross 2 matrix and B is a 2 cross 3 matrix, is 9. So let's check that. So option 4. So we have a matrix A that is of order 3 cross 2 and matrix B that is of order 2 cross 3. So for example, consider the matrix A to be AB, CD, EF and matrix B to be G, H, I, J, K, L. Now if we are going to perform AB, it will be of order 3 cross 3. Okay. So that would be the rows of matrix A or times columns of matrix B. So that would be of our order for matrix AB. So if we are going to perform AB, how are we are going to do? It would be A times G plus B times J, and that would give us our first row, first column entry of matrix AB, AG plus BJ. And similarly, if we are going to find first row, second column entry, that would be A times H plus B times K. So that would be AH plus BK. And that's how we are going to form our matrix AB. Now, the matrix AB would be of order 3 cross 3. So there would be 9 entries in this matrix. So for this reason, we are going to perform this scalar addition 9 times. Hence, the total number of scalar addition that we need to compute for computing matrix AB would be 9. Hence, option 4 that also says that the total number of scalar addition to be done to compute the matrix AB would be 9. So that's why option 4 is also correct. Thank you.